Let's have these five states, A, B, C, D, E, and our inputs are A and B. Okay, step one, is there a dead state, a trap state? Definitely none. Inaccessible state, wherein state A, the initial state, cannot access. There's no path going to that state. Do we have that? None. So therefore, we're not going to remove anything in step one, since there's no dead state, no inaccessible state. Okay, now let's proceed with step two. Get the transition table. So when A encounters A, it goes to B. When A encounters B, it goes to D. In B, when encounters B, it goes to E. If it encounters A, it goes to C. While for C, if it encounters A, it will go back to B. When C encounters B, it will go to E. While D, if it encounters A, it will go back to C. And if it's B, it will go to E. And in E, it will just loop within itself. Okay? So that's step two. So after creating the table, now let's get the equivalency row, which is separating the final state with the non-final state. So the grouping will be A, B, C, D, and then the final state E. So that's equivalency row. Now, step 4, get the equivalence 1. So let's check if A and B are equivalent. So if A encounters A, it will just go to within the group. Okay. How about B? If A encounters C, it will stay within the group. But when B encounters B, it will go to E, which is a different group. Therefore, A and B are different. Okay? Based on based on B. Okay, so A will have a different group from B since they have a different result of grouping with B input. Okay, so A is separate with B. How about C? Is it equivalent to, so we're going to check if C is equivalent to B. C, when encounters A, it will go to B, which is within the group. If C encounters B, it will go to E, which is a separate group, which is the same as B. How about D? D encounters A, will go to C, which is within this group. When encounter B, it will go to E, this group. So therefore, D is the same with C, D is the same as B. Okay? So this will be now the grouping. So A will have a separate group, B, C, D will have one group since they have the same output for A within the group and B referring to E group. Okay, so that's step 4. And then step 5, get the second equivalence 2. So we're going to check BCD is it still the same behavior? Will they give the same path? Okay, so let's check. Step 5, BCD. If B encounters A, it will go to C. Same group. B with E, still go to E. How about C? Encounters A, it will go to B. Same group. C encounters B, will go to E group. Same with B. How about D? C encounters A, go to C. Same group. D encounters B, group E. Same as with B and C. So therefore, B, C, D is still the same in P2. So therefore, since they are the same after P1, so we're going to stop our grouping, and this will be our states. State that contains A, state that contains B, C, D, and state that contains E. So this will be our new automaton. Okay, so A accepts anything, and with its A and B, it will go to B, C, D. Why? Because A go to B, which is this part. B, A, when it's B, it will go to D. Still, this um this state. Okay, and for B, C, D, if it's C, if it's A, we'll just look within C, B, C, which is part of B, C, D. And then if it's B, it will go to E. And then in E, everything will loop. So this should be an end state, by the way. Okay, this E. I just correct it. Okay, so that will be problem 01. Problem 02. Let's have this. Okay, so I proceed with step 2. Okay, so before step 2, no, okay. Let's pause. So let's continue our discussion about problem 02. Let's have this automaton. So again, let's start with step 1. Determine if there is a trap state or unreachable state. Is there a trap state or an unreachable state in this automaton? Yes, we have Q2 and Q4. As you can see, Q2, okay, cannot be accessed by Q0 since it can only path going to Q1 and Q4 only. While in Q4, Q2 could access Q4, but Q0 cannot access it. So that's why we could remove it, since Q2 and Q4 are unreachable. So let's move on with step 2. So in step 2, let's create the table. So for Q sub 0, Q0 rather, so this is the initial state. If it's 0, it will go to Q1. If it's 1, it will go to Q3, which is the final state. And in Q1, if it's 0, it will go to Q0. If it's 1, it will go to a final state, which is Q3. And in Q3, any input will go to Q5. And in Q5, any input will just loop within itself. So this is the transition table. Then afterwards, step 3. So we're going to get the equivalent 0, separate the non-final state with the final state. So we have Q0, Q1, and Q3 and Q5 in a separate group. Then in step 4, we're going to check the behavior of the output when it encounters in the different inputs. Will it go within the same group or not? Okay, so let's start with Q0. If it's 0, it will go to Q1. Same group as with Q1. If it's 1, it will go to another group, which is this group, the output group. While Q1, if it encounters 0, Q0, within the group of Q1, which Q0 is part of it. And when it's 1, it will go to another group, which is the final group. Okay? So in this behavior, when the input is 0, Q0, Q1 goes to within the group. Okay? While if it's 1, it goes to the final state, which is Q3. Okay, so therefore, in step 5, they are still on the same group. While in Q3 and Q5, they have the same behavior regardless if it's 0 or 1. It will just go to Q5. Okay? Since P0 and P1, equivalent 0 and equivalent 1 are the same, so therefore, this is the final grouping. Okay? So when we draw the automaton, we only have two states. We have Q0, Q1, and Q3, Q5 as our final. So when we have 0, it will just loop within Q0 and Q1. Correct. And with this one, it will go to Q3, which is part of Q3, Q5. Correct. And when Q3, Q5 encounters 0, 1, it will just loop within itself. Correct. Since Q5 is part of this final state. So that will be our answer.